Hey, and welcome to 8.4. Today we're going to be measuring arc length, which is where we measure the outside edge of a circle, given that internal degree of, I guess, what we'd call opening. So if I give you an angle of so many degrees, you're going to be able to tell me how far along or what's the distance on the outside edge of the circle. So let's go ahead and let's get started. Okay, so we're going to get started with the title of today's lesson. It's going to be, I think we're on 8.4, which is arc length. And now, what arc length is let's go ahead and let's give a definition. So arc length is, mathematically speaking, what we're going to call the distance along the circumference from one point to another. And this is dictated, or this is told by that internal angle. So we're going to put comma, stated in terms of the internal angle. And so what that means is the fact that if I have, let's move this over, give me some space. If I have a circle right here, and I have a central point, and I have a radius, let's just give it a generic radius, r. The arc length is going to be the distance along the edge from one point to another. So let's say it's from this point to this point. Well, we know that we measure the distance between those points given some internal angle. So we figure out what this angle is, and the arc length is actually the distance between those 2 points. So this would be what we're measuring today. And this is the arc length, is that distance along the edge. We increase the angle, we increase the arc length. And so let's go ahead and let's take a look at a few examples. Okay, so our first examples are going to be examples with radians. So let's write that down. Because remember, we have two different ways that we can record these examples. The first way, using radians, is going to be using our symbol notation. Like, let's say I have our angle is 1 rad, or 1 radian. We're going to do some further examples using degrees, but let's go ahead and let's get started with this. Let's say I have an angle of 1 radian, and I'm trying to figure out I need a radius as well. So let's say a radius of 1. So basically what we're using is we're using the unit circle for this one. So what I'm doing is, I do this in black. So this is what we're going to do. I'm going to draw my circle just to give myself a good sketch so I have an idea of what's going on. So what I know is that my radius is equal to 1, and I know whatever angle I'm looking at is going to be 1 radian. And what I want to find is I want to find this right here. I want to find how long is that segment. Well, let's go ahead and let's build a case for this. I know the fact that the full circumference of any circle is going to be 2 pi r. 2 times pi times the radius. But am I looking for a full circle? No, I'm looking for a fraction of a full circle. So I'm going to introduce a fraction. How much of this circle am I looking at? Well, I'm looking at a percentage of it, 1 radian. Out of, well, how many radians are in a full circle? Well, from what we did in 8.3, we have 2 pi radians is a full circle. So I'm only looking for 1 out of the entire 2 pi. And here my radius is equal to 1. So I'm going to say 2 pi times a radius of 1 times 1 over 2 pi. And I'm going to simplify this, which brings me to 2 pi times 1, which is 2 pi divided by 2 pi. My arc length is equal to 1. So that distance right there, if I have 1 radian, is 1. Seems pretty straightforward. Let's do another one. Let's do another example, except for this time, let's increase our radius. Let's say I still have an angle of 1 radian, but in this time, my radius is equal to 2 units, which means let's go ahead and let's draw ourselves a sketch. I'm going to save some space and draw it a little smaller this time. I have this, and on my radius is 2. But again, I have an internal angle of 1, and I'm wanting to find what is this. So my radius, actually, let me just write that as a 2. So I have an internal angle of 1, and I have a radius of 2, which means that I know the full circle is going to be 2 pi times the radius. I know the fraction of the circle I need is going to be 1 out of a possible 2 pi. So if I fill in what I have 2 pi. This time my radius is 2. And I'm still looking for 1 out of 2 pi. That's a 2, and that's a pi. Okay. Well, if I work this out, I get 2 pi times 2 times 1, which is 4 pi. On the bottom, I have 2 pi. My pi's cancel out. This time, my arc length is equal to 2. And so we notice what's going on here. Every time I have some sort of radian length and I have a radius, it is some multiple of that radius, which is why we use radians. So let's do one more example. Let's change them both this time. Let's say I have an example instead with arc length. Let's give it not a whole number, let's say pi radians. And so if I have pi radians, let's also give myself a radius, which is slightly bigger. Let's say 15. And so what we're going to notice is that given our circle, I know that I'm wanting to find some angle pi. And now you might realize that this isn't necessarily drawn to scale because how many radians are in a full circle? 2 pi. So what would pi be? Pi would actually be half of a circle. This would be pi. But it doesn't necessarily need to be drawn to scale because the formula of the process is going to be the same. So I'm showing you how to do it. As you get further and more advanced, you realize, hey, I should technically draw this all the way across. But just so that we have a similar setup for all of these, I'm going to draw this generic angle and label what's in there. I also have a radius of 15. So I know in this case, the arc length of an entire circle, which is not what we're looking for part of a circle, would be 2 pi r. And I know it would be some fraction of the entire circle. The entire circle would have 2 pi radians all the way around it. I'm only looking for pi, which means 2 pi, my radius of 15, times pi over 2 pi. Okay, well, first I notice 2 pi times 15 times pi is going to be 30 pi squared because I have 2 pi's, so pi squared, over 2 pi. 30 over 2 reduces down to 15. Pi squared over pi, one of those pi's cancels out, and I'm left with a single pi. And I have an arc length of 15 pi. I could have reduced that by saying 2 pi and 2 pi cancel out, and I just have a 15 pi left, or I could work it all the way out and come back. So those are 3 good examples of what it looks like to deal with a radian. Okay, so next up we're going to be using examples using degrees. These are going to be a little bit more familiar and a little easier to understand for some of you because you're more prone to looking at a circle and thinking in terms of degrees instead of in terms of radians. Radians are still a very new topic for a lot of you. So let's go ahead and let's cover a few of these just to make sure that we understand the point. And let's start out with an internal angle of 180 degrees. Let's follow that up with a radius of 1. So we know that 180 degrees is half of a circle. Radius of 1, we should know that a full circle, if the outside edge is 2 pi, half of a circle should be pi. So let's go ahead and let's check out this process to make sure we understand what's going on. So if I have a full circle with a radius of 1, and I'm looking for 180 degrees, that means I've gone halfway around the circle. I'm going to extend that to 180 degrees, which means I'm trying to find the length of this segment right here, or that arc right there. So I know the full circle is going to be 2 pi r. But again, I'm only dealing with a fraction of the circle. So how many degrees are in a full circle? Well, there's 360. And I'm only using 180 of them. So that's where I get half of a circle, half of this circumference. So if I fill this in, 2 pi times 1 times 1/2 of a circle, 2 pi times 1 is 2 pi divided by 2. That means my arc length is pi. And so we see the process is no different than what we've been doing, which is dealing in units of degrees as opposed to in units of radians. So let's do one more. So let's do this time, let's say an internal angle of 90 degrees, and let's give us a radius of 4. And so if I draw my sketch right here, I know that I have a radius of 4, and 90 degrees, that's going to be 1/4 of the way around the circle. Because if a circle has 360 degrees, that's going to be 1/4 of the way around it. So you already know the fraction. But we're going to go ahead and we're going to work this out. So I want to find the length of that arc right there. I know the full circle is going to be 2 pi r, and I'm only dealing with part of a circle. Full circle would be 360, but I'm only dealing with 90 of those 360. That's where the 1/4 comes from. So if I fill this in, 2 pi times 4 times 1/4, that gives me 2 pi times 4 times 1, 8 pi over 4. 8 over 4 reduces down to my arc length here is 2 pi. And I apologize about the wobble. I'm trying a different format here, and I hope that the image is a little clearer, but it wobbles a little bit. But so we can see the fact that our examples using degrees are no different. I take a full circle circumference and I figure out the ratio or the fraction of what I'm dealing with. Now, could we have a fraction larger than 1? Yeah. If I'm doing 2 circles, I would just have 720 over 360. It wouldn't make that much of a difference. So we notice the fact that we've created what we call a generic formula because we've done it several times. Our arc length formula is equal to 2 pi r divided by the degrees divided by the full circle. Now, this is the internal angle. If the full circle, I either have one of 2 ways I can do this. I can either do this in 360 for a degree circle, or I can do it in 2 pi for a radian circle. So I'm going to say this is radians because I'm dealing with 2 pi. If I wanted to use this same equation with degrees, it would just be 2 pi r, whatever angle out of 360. You fill in your radius, you fill in your angle, you fill in your radius, you fill in your angle. This actually does reduce. So now my arc length generic formula, the 2 pi's cancel out. It is just the radius times the angle. This doesn't simplify at all. So here are our 2 formula, and that concludes 8-4.
Okay, so that's the end of 8.4. So realize we had two things that we learned. If we want to find the area or the length of the outside edge of the circle, we need to know two things. The first thing, we need to know the radius. How big is the circle? Because the bigger the circle, the bigger that length. The second thing is we need to know, are we using degrees or are we using radians? The only thing that we need to know about that is when we plug that into the fraction. If we're dealing with radians, we're going to be dividing by 2 pi. If we're dealing with degrees, we're going to be dividing by 360. And that's it. So remember, you take the full circle, which is 2 pi r, and multiply it by the fraction of the circle of which you get. And that's all it takes to measure arc length. Remember, if you have any questions, let me know.